In this particular session, we're going to be looking at indices or powers. Either name is used, both mean the same. Basically, they're a shorthand way of writing multiplications of the same number. So here we have 4 multiplied by itself 3 times. So we write that as 4 to the power 3. So it's 3 that is the power or the index. So that's the index or the power. We can do this with letters. So we might have A times A times A times A times A, and that's A multiplied by itself 5 times. So we'd write that as A to the power 5. What if we had something like 2x squared raised to the power 4, let's say? Then that would mean 2x squared multiplied by 2x squared multiplied by 2x squared multiplied by 2x squared. 1, 2, 3, 4 of them all together. So we can do the 2's together. 2 times 2 times 2 times 2. That gives us 16. And x squared times by x squared is x to the power 4. Times by another x squared is x to the power 6. Times by another x squared is x to the power 8. Okay, we've got a notation. We've got a way of writing something down. Now, when mathematicians have a notation and they've got a way of writing something down, they want to be able to use it for other purposes. So, for instance, what might a to the minus 2 mean? We know what a to the power 2 would mean, but what about a to the minus 2? What would that mean? What would something like a to the power a half mean? What might something like a to the power 0 mean? Well, we need some rules to operate with, and out of looking at these rules, we'll find what these particular notations actually mean. So let's begin with our first rule. Supposing we have a cubed and we want to multiply it by a squared. What's our result? Well, we know what a cubed is. That means a times a times a 3 times. Times by a squared, so that's a times by a on the end there. And altogether we've got 5 of them. A to the power 5. And that suggests our very first rule, that if we're multiplying together expressions such as these, then we add the indices. And so if we have a to the m times by a to the n, then the result is a to the m plus n. And that's our first rule. Let's have a look at our second rule. We've already done something like this previously. Supposing we had a to the power 4 and we wanted to raise it all to the power 3. And we know what that means. It means a to the power 4 times by a to the power 4 times by a to the power 4. And our first rule tells us that we should add the indices together. So that's a to the power 12. 4 plus 4 plus 4. But 12 is 3 times by 4. So that suggests to us that we should perhaps, if we've got a to the power m raised to the power n, then the result we get by multiplying those two together. And that is our second rule. Let's now have a look at our third rule. For this, let's take a to the 7th and let's divide it by a to the power 3, or a cubed. Well, a to the 7th means a multiplied by itself 7 times. Divided by, so let's divide it by a multiplied by itself 3 times. And now we can begin to cancel some common factors. So there's a common factor of a. And again, there's another common factor of a. And again, there's another common factor of a. So on the bottom here, we've really got 1, 1, and 1. So if 1 times 1 is 1, and on the top, a times by a times by a times by a to the power 4. But 7 take away 3 is a to the power 4. And so that gives us our third rule, that if we have a to the power m divided by a to the power n, we get the result a to the power m minus n. And so there's our third rule. Okay, we've got 3 rules. Let's see what we can do with them. Let's have a look at a cubed divided by a cubed. Well, we know the answer to that. A cubed divided by a cubed, we're dividing something by itself. So the answer has got to be 1. Fine. Let's do it using our laws of indices, our rules. And we can use rule number 3 for this, that if we want to do this, we subtract the indices. So that's a to the power 3 minus 3, which is a to the power 0. So what have we done? We've done the same calculation in 2 different ways. We've done it correctly in 2 different ways. So the answers that we get, even if they look different, must be the same. And so what we have is a to the power 0 equals 1. Our fourth result, if you like. What does this mean? In effect, it means that any number raised to the power 0 is 1. So if we take 2 and we raise it to the power 0, the answer is 1. If we take 1,000,000 and raise it to the power 0, the answer is 1. If we take something like 1/2 and raise it to the power 0, the answer is again 1. If we take -6 and raise it to the power 0, the answer's 1. If we take 0 and raise it to the power 0, well, it's a bit complicated, so we'll leave that one on side. For the moment, just bear in mind, any number apart from 0, when raised to the power 0, is equal to 1. Let's have a look now at doing a division. Again, let's take the example that we used when we looked at law 3. Except let's turn it round. Let's do the division the other way about. A cubed divided by a to the 7th. Well, we can set that out as we did before, except it will be the other way up. So we have a cubed is a times by a times by a, divided by a multiplied by itself 7 times. And again, we can do the cancelling out the common factors, dividing top and bottom by the common factors. So what do we have? 1 on the top, 1, 2, 3, 4 on the bottom, a to the power 4. We know we've done that right. Let's use our third law, our third rule, and do it by subtracting the indices. Well, 3 take away 7 is minus 4. So we've got a to the power minus 4. So, same argument applies. We've done the calculation, same calculation, in 2 different ways. We've done it correctly. We've arrived at 2 different answers. Therefore, these 2 answers have got to be the same. So 1 over a to the power 4 is a to the minus 4. So a minus sign in the index with the power means 1 over. 1 over a to the power 4. Let's just develop that one a little bit. Let's just look at 1 or 2 examples. So for instance, 2 to the power minus 2 would be 1 over 2 squared, which of course gives us a quarter. 5 to the power minus 1 is 1 over 5 to the 1, which is just 1 over 5. 1 over a is a to the minus 1, turning it round, working backwards. 1 over 7 squared would be 1 over 49. But what about 1 over 7 to the minus 2? Minus 2, remember, means 1 over 7 squared. This is 1 over 7 squared. And here we're dividing by a fraction. And to divide by a fraction, we know that we invert and multiply. And so 7 times by 7 is 49, times by the 1 leaves us with 49, or just 7 squared. So some examples there. This is probably the one that you'll need to remember and need to work with most. It's the basic case, and if you can remember that one, then they nearly all follow from that. So, that's that one. Let's now go on and have a look at our 6th result. What do we mean by a to the power a half? What's that mean? So far we've been working with integers and with negative numbers. But what about a to the power a half? Well, supposing we had a to the p and we multiplied it by a to the p, and the answer we got was just a. Just a, that's a to the power 1. And a times by a, each with a p on, a to the p times by a to the p, using our rule, would be a to the 2p. So 2p must be the same as 1. In other words, p is a half. Well, do we have some sort of interpretation for this? 2 numbers, identical, that multiply together to give a. Well, that's the square root, isn't it? It's a square root. It's like 7 times by 7 equals 49. So if we take that one on, 7 times by 7 is 49. What we've got then is 49 to the half is equal to 7. So a to the half is equal to the square root of a. A to the third would be equal to the cube root of a. So if we were asked what is 16 to the quarter, what we're asking is what number, when multiplied by itself 4 times, gives us 16. And a fairly obvious choice for that is 2. What about 81 to the half? Well, that's the square root of 81, and the square root of 81 is 9. What about 243? And we'll make that to the 5th. What number, when multiplied by itself 5 times, will give us 243? Well, as we look at this, we can see it divides by 3, and 3's into that give us 81. So we know this is 3 times by 81. 81, we know, is 9 times by 9. And each of those 9s is 3 times by 3, which means the number that we want is just 3. Notice in doing this how important it is to be able to recognise what numbers are made up of, to be able to recognise that 16 is 2 to the power 4, that it's also 4 to the power 2, that 9 is 3 squared, that 81 is 9 squared and also 3 to the power 4. You'll find calculations much, much easier if you can recognise in numbers their composition as powers of simple numbers such as 2 and 3, 4 and 5. Once you've got those firmly fixed in your mind, this sort of calculation becomes relatively straightforward. One final result. If we now know what a to the half is, and a to the third, and a to the quarter, what do we mean if we take a to the 3/4? Well, the quarter's all right. So let's split that up. That means a to the power 1/4 cubed. And what we're doing is we're using this result, that a to the m raised to the power n is a to the mn. In other words, we're using our second result to be able to do that. So, let's have a look at an example using this. Supposing we take 16, and we say we want 16 to the power 3/4. Then that's 16 to the power 1/4 to be cubed. So we look at this first. 16 to the power 1/4 is 2. That's the number when multiplied by itself 4 times will give us 16, raised to the power 3. And that, of course, is 8, because that means 2 times 2 times 2. But we can think of this another way, because m and n can be interchanged, can't they? We could write this as a to the power n raised to the power m. And that would be just the same result. So we can think of this in a slightly different way. Let's take a different example. Let's take 8 to the power 2/3. Now, the way that we had thought about that was to do 8 to the power 1/3 and then square it. And we know that 8 to the power 1/3 is 2, and that 2 squared is therefore 4. But we don't have to think of it like that. We can think of it as 8 squared raised to the power 1/3. 8 squared we know is 64, and now we have to take it to the power 1/3. We need the cube root. We need a number that when multiplied by itself 3 times gives us 64. And that number is 4. These two are equivalent. So the different interpretations that we've got are the same. Writing it down algebraically, what we're saying is that we have a letter, a variable, to the power p over q, then we can write that in one of two ways. we can write it as either a to the power p, find the qth root of it, which might be written as a to the power p, find the qth root, or it might be written as a, let's take the qth root and raise it all to the power p. So we might have a, find the qth root of it, and raise it all to the power p. Either result is exactly the same. Now, to conclude, let's just have a look at some very basic, simple calculations using indices. 2x to the minus a quarter. And our object here is to write it with a positive index. Well, the 2 doesn't have an index attached to it at all, so nothing happens to the 2, it just stays as it is. X to the minus a quarter. The minus sign means 1 over. Write it in the denominator. So we write it down there. So we have 2 over x to the power a quarter. 4x to the minus 2 a cubed. Well, nothing wrong with the 4 and nothing wrong with the a cubed. They're perfectly normal, so they stay as they are. X to the minus 2. A minus in the index, and so that means 1 over. So it's 4a cubed over x squared. 1 over 4a to the power minus 2. Well, we've met this one before. If you remember, we actually looked at 1 over 7 to the minus 2. And that was 1 over 7 squared. And because we were dividing by a fraction, we said we had to invert and multiply. And so we ended up with 7 squared. This is no different. There's a letter there instead of a number, but the result is going to be exactly the same. So the 4 stays where it is, 1 over 4, and this becomes a squared. And to write it in a more simple, tidier fashion, it's a squared over 4. A to the minus a third times by 2a to the minus a half equals, the 2 we can just write down. A to the minus a third times by a to the minus a half. Our first job is to add those indices together. So minus a third plus minus a half is going to give us 2a to the power. Now, a third and a half is 5/6, so with the minus signs, that is minus 5/6. And so that's 2 over a to the power 5/6. Two a to the minus 2 divided by a to the minus 3 over 2. Well, that's 2a to the minus 2 divided by a to the minus 3 over 2. Let's remember what our rule said, that if we're dividing things like this, we actually subtract the indices. So this is 2a to the minus 2 minus minus 3 over 2. Of course, that means effectively we've got to add on the 3 over 2. So we get 2a to the minus 2 plus 3 over 2, which is minus a half. And so that's 2a over a to the half. Now then, if we take something that looks a little bit complicated, So what have we got here? We've got the cube root of a squared times by the square root of a cubed. First of all, let's write these as indices. This is the cube root of a squared. So that means a squared and take the cube root. In other words, a to the 2/3. Times by a. Now this is a cubed, take the square root. So that's a cubed, take the square root. And we can see now that what we need to do is add together these two indices. So that's 2/3 plus 3/2. And adding fractions together, that will give us a to the power 13/6. Awkward number, we'll just leave it like that for now. Now let's have a look at some calculations using numbers this time. 16 to the power 3/4. Now again, we've already done this one. That's 16 to the power 1/4 cubed. What number, when multiplied by itself 4 times, gives us 16? Well, that's 2. Raised to the power 3 gives us 8 for our answer. 4 to the power -5/2. Let's deal with the minus sign first. Minus sign means 1/. Put it into the denominator. 4 to the power 5/2. 1/4 to the half to the power 5. Notice each time I'm doing the root bit first. The 4th root here, the square root here. That's because by doing the root I get the number smaller, I can handle the arithmetic easier. So this is now 1/, the square root of 4 is 2, raised to the power 5, and that's 1/32. Again, notice I wrote it straight down without seeming to work it out. That's because I know what it is. And again, it's another one of these relationships. 2 to the power 3 is 8, 2 to the power 5 is 32, 2 to the power 6 is 64, that really, if you can learn and become familiar with, you'll find this kind of calculation much easier. Here's another one. 125 seems a very big number. To the 2/3 equals 125 to the power 1/3 all squared. Now, even if we've never met 125 before in these terms, one of the things we ought to be aware of is it ends in a 5, so it must divide by 5. So it's a fair guess that 5 multiplied by itself 3 times would give us 125. And indeed it does. So to the 3rd power, 125 to the 3rd power is 5. The number multiplied by itself 3 times that gives us 125 is 5. And now we just want to square that, and that obviously gives us 25. Let's take 8 to the minus 2/3. Again, let's deal with the minus sign. That is 1/8 to the 2/3. Again, let's deal with the 3rd bit, the root bit first. What number, when multiplied by itself 3 times, would give us 8? Well, that must be 2, and we need to square it. And so that becomes 1/4. We take 1/25 to the minus 2. Well, remember we saw what this happened with the 1/7 to the minus 2. This became 25 squared. And that is simply 625. 243 to the 3/5. Let's do the 5th bit first. and then the cubing. Well, 243, that's 3 multiplied by itself 5 times. So that is a 3 raised to the power 3, and that's 27. One last example. Let's take 81 and to the minus 3/4. Okay. Minus sign means 1 over. We're dividing by a fraction. To divide by a fraction, we invert and multiply. So this becomes 16 over 81 raised to the power 3/4 equals 16 over 81, first of all to the quarter, and then raised to the power 3. To the quarter, this is 2 to the power 4 on top. 16 is 2 to the power 4, so that's a 2. And 81 is 3 to the power 4, so that's a 3. And we need to cube that, and that gives us 8 over 27. So working with these indices shouldn't really be too difficult. You need to remember how numbers are made up. You need to have in your mind's eye that 243 is 3 multiplied by itself 5 times. 243 is 3 to the power 5. And similarly with numbers like 32, 64, 128. If you can carry those around in your head, and you will do with practice, you get to know them quite well, then this kind of calculation should become very easy to you. Remember, deal with the minus sign first by and large, get that to be positive, then deal with the root sign. That gets the number worked down, keeps it small. They can be tricky, but we hope we've shown that they can be mastered.